So we can represent it by O, directed line segment OC, or vector C, which is equal to the ordered pair -2 and -3. So we have here, let a body move from A to B. After covering 4 units to the right, then 3 units up. So if we want to move from A to B, we move 4 units right, then move 3 units up, represented by the displacement vector to the body from A to B, which is AB vector or AB directed line segment. It's possible to represent AB directed line segment in the orthogonal coordinate plane by an infinite number of parallel directed line segments equivalent to AB, and one of them is the position vector ON, and AB vector can be equivalent to DE vector, can be equivalent to infinite number of directed line segments. One of them is the position vector ON, which is 4 and 3, because we move 4 units in x-axis, then move up 3 units, so the end point of ON, the position vector, is 4 and 3. So if you want to find the norm of AB, we can find the norm of the position vector ON by using the rule of norm, which is square root 4 power 2 plus 3 power 2, which is equal 5 length units. So each one of the equivalent directed line segments, its norm equal 5 length units. So we have here an example in figure opposite. Determine the position vector of point C with respect to the origin point O. Find its norm. So we have here OC, the directed line segment OC. We move on x-axis to right 1, 2, 3, 4, 5, and move down 2 units. So the point C is 5 and -2. So the point C is 5 and -2, and its norm square root 5 power 2 plus -2 power 2. So 5 power 2, 25, 2 power 2, which is equal to 4. So square root 29 length unit. So its norm root 29 length unit. So determine all vectors such that each of them is equivalent to OC. So we want to find all vectors which have the same direction as OC and same norm or same magnitude. So we will take LZ, because LZ have the same direction, and LZ we move right 1, 2, 3, 4, 5, then move 2 down. So LZ is equivalent to OC. So OC equivalent to the first one is LZ, and we have here NM in the same direction. So we have here N. Let's find the norm. We move right 1, 2, 3, 4, 5, then move down 2 units. So 5 and 2 also. So NM in the same direction and same norm. So NM is equivalent to OC. And we have DE in opposite direction, so it's not equivalent. We have AB different norm, because A to B we move right 1, 2, 3, 4, 5, 6, 7, then move down 3 units, so not have the same norm. And we have FK in opposite direction, so it's not equivalent. So OC is equivalent to LZ and NM. LZ directed line segment and NM directed line segment. And we have an example In coordinate orthogonal plane, if A 4 and negative 3, B 4 and 4, C negative 3 and negative 1, and B a directed line segment and CD directed line segment, and the directed line segment OM and NO are equivalent directed line segments where O is the origin point. Find the coordinate of D, M, and N. So inlets will represent the points A, B, and C. So we have here the point A 4 and negative 3, so 4 we go 4 units, then move down negative 3 to negative 3, so the point A here 4 and negative 3, this is point A, and point B 4 and 4, so we go from 4 to 4, so the point B here 4 and 4, and C negative 3 and negative 1, negative 3 then go down to negative 1, negative 3 negative 1, the point C. So we have BA is equivalent to CD, so we have BA, so I move from B to A, so draw line from B to A. So here we move from B to A 7 units. Why? So I move from B to C 7 units because we have here 1, 2, 3, 4, 5, 6, 7, or we can say 4 minus negative 3, 4 minus negative 3. So end minus start or start minus end. So this is equal 7 units. Its norm equals 7 units. So we can deduce that if we have B, A, we can make A minus B. It's mean 4 and negative 3 minus B, which is 4 and 4. So it's equal 4 minus 4, which is equal to 0, and negative 3 minus 4, which is equal to negative 7. And norm of BA, algebraic, we can say 0 power 2 plus negative 7 power 2, which is equal to 7. So we can say A minus B, which is equal to negative 3 minus 4, which is equal to 7 units. So from C we can move 7 units to the point D. So we can deduce the position of the point D. So I will count 1, 2, 3, 4, 5, 6, 7. So I will stop at this point, which is negative 3 and negative 8. So we move from the point C to the point D 7 units because CD is equivalent to AB. So its norm equals 7 units. So D equal negative 3 and negative 8. The point D negative 3 and negative 8. So if you want to find OM, so we'll move from O to the point M 7 units in same direction of BA. So OM I will move 7 units, so I will stop at negative 7. So 0 and negative 7. So this OM. I move from the origin point to the point M by the same norm of BA because OM is equivalent to BA. So the point M equal